Hello, in this podcast I'm going to model for you how to do a student-designed or SDL lab. The objective for these labs is that you design an experiment. Typically, we will be doing this once as a class, and those of you who need to make up a lab, like if you are absent, this is the kind of lab which I will assign for you to do at home if the lab cannot be made up, and a lot of our labs which involve equipment cannot be made up. So here we have a typical SDL lab, and in these labs you design an experiment, you don't actually do the experiment. And the first part is the thing which sets the actual question, and you have a scenario and a problem, and the problem is the question you're going to be answering in designing your experiment, and the scenario is what brings about the question. So the scenario is that Tamara knows that plants need sunlight for photosynthesis. She wonders if plants respond to sunlight by producing larger leaves. This brings about the problem or the question, does sunlight affect leaf size? The first part of your lab is the part where you identify things, which will help you in the second part where you write the procedure. And the first thing we're looking at here is the hypothesis. And the hypothesis is a prediction that answers the question. It is not a question. If you write the hypothesis as a question, then I'm going to mark the lab as unsatisfactory, and you're going to have to redo this and hand it in for a regrade. So the prediction, does sunlight affect leaf size? Here's a possible hypothesis. When there is more sunlight, plants will grow larger leaves. You could also write down that when there is more sunlight, plants will grow smaller leaves. Or you could say that sunlight has no effect whatsoever on leaf size. All those are possibilities. Doesn't make a difference what the answer is so long as it is a valid prediction that answers the problem. The next two, independent variable and dependent variable. These variables you always find in the hypothesis. The hypothesis has always at least two variables, and usually it only has two, and two of those variables are always the independent and the dependent variable. You can figure out which is which by examining the hypothesis. Now, if you look at this hypothesis, there are two different variables. One variable is the amount of sunlight, and the second variable is leaf size. You have there one particular value of it, and that larger leaves, it could just easily be smaller leaves. They're just showing in your hypothesis, just showing one value of it. And you have to just ask yourself, which value depends on the other? The one that depends on the other is the dependent variable. The one that does not depend on the other, that's independent of the other, is the independent variable. And actually the independent variable is independent of any changes that go on in the experiment usually. Its value is usually set by the scientist. So when we look at our hypothesis, which one depends on the other? Does leaf size depend on the amount of sunlight? Or does the amount of sunlight depend on leaf size? Well, the leaf size does depend on sunlight. So amount of sunlight is the independent variable, and leaf size is the dependent variable. Now the next one, constant variables. Constant variables are sometimes called controlled variables or control variables. And there are lots of these. These are values which remain constant from each of your trials, and if their value changes, they change equally in each trial. And it has to be like this, because if they do change, then they may end up replacing the independent variable as the one that changes larger leaves. You'll see in a moment with the two that I picked here. Two that I put down, and there are a lot more than just these two, are the type of plant and how much they are watered. And to show you how it can change, you look at the type of plant. If you change what kind of plant you have, that will change the size of the leaf. So it wouldn't be dependent on, so the leaf size isn't dependent so much on the amount of sunlight as it is the type of plant. So you have to keep it the same kind of plant in each of your trials. Now we come to the second part where we're going to be using each of the values that we have. A step-by-step procedure on testing the hypothesis, and then you finish with writing a data table. So step 1, make 2 groups. You always have to have 2 groups. And usually you will have to have a control group. In this case, we can do a comparison without the control group. The control group, the comparison here we have one has 12 hours of sunlight per day, and the other group gets 3 hours of sunlight per day. Now, a control group is a group where the independent variable's value is 0. And here it doesn't make sense to do that, because if it's 0, then the plant would die because it wouldn't be able to get any photosynthesis done at all. Frequently where you have a control group would be if you want to see if say particular medicine has an effect, and there the control group would not get any medicine. It would instead get a placebo. Second step is where we put in our, like the first step here, we change the independent variable. We have 2 groups, we're changing that to sunlight. Now we are putting in the constant variables. Both groups have the same kind of plant and will receive the same amount of water each day. And then, last one, it's not a long procedure. After 3 weeks, we measure the area of each leaf and record the average leaf size. And then we have our data table. Now the data table will need to have 2 columns. The first column is for the independent variable. Second column, the dependent variable. So you have the amount of sunlight and average leaf area, and made one little mistake in here, and can you spot the mistake? Mistake is that I only have one actual row for putting in the data, though I would actually not mark this unsatisfactory if you have everything here. You need to have 1 row for 12 hours of sunlight and 1 row for 3 hours of sunlight. Do not put any data in there, because you're not in SDL Labs, you're not actually doing the experiment, you're only designing the experiment. And that basically completes the lab. So you do this and you hand it in to me. If you still have questions, please talk to me after class or after school, or just email me.